32. Nice. Okay. So today's we are going to discuss with the speeds cost of memories. So before going to be discuss with this one, so memory hierarchy we need to be identify. We need to be know what actually the memory hierarchy. Why this is going to be introduced. So here you have to see this. The memory is the memory in a computer can be divided into 5 hierarchies based on the speed as well as use. Depending upon the speed as well as the use, the memory hierarchy can be divided into 5. So the processor can move from one level to another level based on its requirement. So the processor can be moved one level to another level based on its requirements. The 5 hierarchies in the memory, these are 5 memories: registers, cache memory, main memory, magnetic disk, and magnetic tapes. So we already discussed at the first starting of the session. So 5 hierarchies we are already discussed with this one, and today we are going to be discuss a little bit more about memory hierarchy. So the first 3 hierarchies are volatile memories. Volatile memories in the sense it doesn't retain the data, which means, so here if in case the power no power, so power in case the no power, data doesn't retain, we are not able to retain the data, and then automatically loss their store data. They store data means whatever we store the data that can be automatically lost whenever the power is off. Whereas the 2 hierarchies are not volatile, means they are non-volatile, permanently stores the data. So the memory element is the set of storage devices which stores the binary data in the type of bits. In general, the storage of memory can be classified into 2 categories, such as volatile as well as the non-volatile. So memory hierarchy architecture, we are going to be see how the memory are going to be architecture can be designed. So the memory hierarchy design in computer system mainly includes different storage devices. Most of the computers were inbuilt within extra storage to run more powerfully beyond the main memory capacity. The following memory hierarchies diagram is hierarchy pyramid for computer memory. The designing of the memory hierarchy is divided into 2 types, such as primary and secondary memories. So here you have to see that this is the architecture for the memory hierarchy. So these can be designed in level by level. So here at the first starting level, registers, cache, main memory, electronic disk and magnetic disk, optical disk and magnetic tapes. So these are arranged in level by level. Okay. See here, registers are in level 0, cache is level 1, and main memory is level 2, and this one magnetic disks are level 3, and optical disk and magnetic disks are level 4. These are arranged in level by level. So come on to the capacity in the sense storage. So come on to the capacity. From here we have to see this. So from top to bottom, what happens? It's going to be decrease the capacity, means this requires less capacity and this requires little more bigger one. Here we have to see this, that can be in KB to MB, the data may be storage may be required, and here GB to TB the capacity is required. Here terabytes of data. So where exactly the terabytes of data we are having? In HD hard disk, and this one is, and GB and terabytes, these are DDR4. RAM memories. Remember, RAM memories DDR4, DDR3, DDR1, like that. And compared to the latency. So here, top to bottom, this can be high to low latency. So here, why we are going to be getting less capacity over here, the registers, because to speed up the system, so this requires only less capacity. That's the reason the system may be speed up when using the registers. If you use the CPU caches, so the system may be little bit more speed up them compared to registers. That's why these are going to be arranged in level by level. So here, depending upon the class cycle also, class cycle in this is a fraction of nanosecond. So within the nanoseconds, how the data may be transferred from one memory to another memory. Here, registers takes 1 cycle, so cache takes 10 cycles to read the data or to write the data and to fetch the data. So we need to be executing something. So it requires 10 cycles in cache. In main memory, 100 cycles is required. And flash disk, that's require 1 M takes cycles, 1 megabyte cycles, and traditional disk that requires 10 M cycles, like this. And compared to speed, so here we already discussed this capacity. Capacity is from top to bottom. It's top to bottom. Capacity is all increased. From bottom to top, the speed may be increased from bottom to top. Here the speed is very less. Latency. So here already we have seen this one. This is the latency. So speed. Latency in the sense speed. So from here the speed is very less. If you use terabyte, petabyte of memories, the speed become not much faster than the registers compared to registers and flip-flops. So as well as in local storage, hard disk, floppy disk. So in RAM, compared to RAM become the speed become 10 to 30 nanoseconds. Within 10 to 30 nanoseconds, it's going to be fetching the data or writing or reading the data. And cache, that requires 3 to 10 nanoseconds, and registers and flip-flops, this requires 1 nanosecond, less than 1 nanosecond. That's the reason this become very costly, and this become low cost. This is not an expensive one compared to registers. Registers are very expensive one. Why? Because within 1 nanoseconds, below 1 nanoseconds, this is going to be executing the data whatever the user can give in. So the same way here also see. So here also we have to see this one, increasing the size from top to bottom. Size may be increased, and increasing the speed from bottom to top. The speed may be increased, and cost also. Here we have to see this. The cost also increase automatically. If the speed is increased, the cost also increased automatically. So if you want to purchase these registers, you need to pay more money compared to magnetic disk. That's the reason they are very expensive one. Registers are very expensive one. So same diagram over here. So here the capacity. So it is the global value of information. It is the global value of information the memory can store. As we move from top to bottom, the hierarchy, the capacity is increased. Right? Top to bottom, the capacity is increased. Here you have to see this small size, small capacity, small size, small capacity, and then large size, very large capacity. Here we are using in bottom we are going to be using tapes. That's the reason the cost may be very low, and this size become very large one. Tapes are petabyte. In petabyte also uh, we are going to be add external. So access time. So we already know access time. So it is the time interval between read and write request. So depending upon the read and write request, if one user going to be asking requesting for read or writing operations, so how much time it's going to be taking. So that's is required and availability of data. The data may be available at the time of when the user is request. So if the data is available at the time when the user is trying to read, so within how much speed we are going to be getting the data, 1 nanosecond, 10 nanoseconds, is completely depending upon what we are going to be using the register. If you use the registers or any main memories, caches, it's completely depending upon that one. So as we move from top to bottom, the hierarchy, the access time is increased. Here hierarchy, the access time is increased top to bottom. So top to bottom, tapes are very speed. Tapes are having more capacity, but the speed is very less, and registers having less capacity, but the accessing speed is very high. Quickly we will get the data when a user requests a read or write request in case. So compared to performance, come on to the performance. Earlier when the computer systems doesn't uses the memory hierarchy. So that's the reason the speed gap increases between CPU registers and main memory due to the large differences in access time. So in previously memory hierarchy design never maintains. Without memory hierarchy, they are going to be given on market. Systems are developed. They are going to be develop the systems, computer systems. So whenever these systems are come onto the market, so the access time may be vary from the CPU registers and main memory. So this results lower performance. So without using the memory hierarchy, the results use lower performance and system is very slow down. So enhancement is required. So they are thinking about that one. So without maintaining memory hierarchy, less performance we are getting. So how they are going to be increasing the speed and performance? So that's the reason the memory hierarchy may be designed. So the performance of the systems is increased. Performance of the system is increases automatically. So whenever we use the memory hierarchy design, the system should be automatically increase the performance. So previously doesn't uses the memory hierarchy. That's why the systems are very low performance. Now we are using the memory hierarchy design. So that's why the systems maybe performance speed up compared to previous one. The most of the significant ways to increase the system performance is minimizing how far down in the sense reducing the distance for calculations. Means when you get the fetching the data from one component to another component, so there is no distance. Distance may be increased in previous. So right now the distance is very compared to previous systems. The distance is very means less distance compared to previous one. Quickly we will get data, then the system performance is automatically increases. The memory hierarchy has to go to multiple data. So when you fetching the multiple data, so if the distance is more, means if you want to store some data that can be stored in somewhere, means the distance is more. సో అది వేరే డిస్టెన్స్లో ఉందనుకోండి, దాన్ని ఫెచ్ చేయడానికి టైం తీసుకుంటుంది. సో ఆ టైం తీసుకునే టైం పీరియడ్ని తగ్గియడం అనేది జరుగుతుంది అనమాట. ఈ మెమరీ హైరార్కీ ద్వారా ఈ డిజైన్ చేయడం వల్ల ఆ టైం అనేది రెడ్యూస్ చేయడం వల్ల ఆటోమేటికల్లీ పర్ఫార్మెన్స్ అనేది ఇంక్రీజ్ అవుతుంది అనేసి ఈ మెమరీ హైరార్కీ అనేది డిజైన్ చేయడం జరిగింది అనమాట. సో కంపేర్ ఫోర్త్ వన్ ఈజ్ కాస్ట్ పర్ బిట్. As we move from bottom to top on the hierarchy, the cost of the bit is automatically increases. Yes, that is, memory hierarchy is costlier than the external memory. So internal memory is costlier. So here internal memories are very cost. This compared to secondary memories, disk and hard disk, tapes and hard disk. Okay. And then same as it is the same diagram. Memory speed is automatically increases and cycle time is down at the time of accessing. So here the cost is increases. So if you want to buy the registers, the cost is automatically increases. If you want to buy auxiliary memories, that is secondary memories, the cost is less compared to registers. And then volume size is increases. So here the register's volume size is less. Volume means the storage capacity. So here the auxiliary storage capacity become high and the same. So registers are closest position in respect to the processor ALU. It is a set of processor register. It features a very low access time, small volume, high cost bit and high speed. Same as it is this one. So where exactly the cache is laid become, this is going to be laid in between register memory and main memory. The cache may be laid, and here we have to see the cost and performance. So components are given: CPU and cache, main memory, disk memory, tape memory. So here the axis is random axis in CPU, cache and main memory. Randomly they are going to be accessing the data, but in disk memory directly we will get accessing the data, and tape memory sequentially. And the capacity is here in bytes they are going to be given. CPU 64 to 1 KB and cache is 4 MB, main memory 4 GB, 8 GB this one, and 1 terabyte this one. And latency, so here the latency is latency is speed, how speed it's going to be working on it. So here 10 nanoseconds, 20 nanoseconds, 50 nanoseconds, so 10 microseconds to 10 seconds. And block size is it requires only one block, but the cache is requires 16 blocks, and tapes are required 4 KB. 4 KB blocks are required at a time. Block size is 4 KB at a time. The data may be stored at a time. 4 KB of data it's going to be stored. In capacity, one word only, it's going to be calculate or getting the data. Here 16 words it's going to be fetching and calculating that one, whatever the user request, depending upon the user request. And the bandwidth is system clock rate. Bandwidth, this is also speed, how speed it's going to be working on it. So this is the bandwidth, and this one is the cost. This one is high, very high CPU when you buy, and this one is $50, this one is 75, $0.71. Here dollars are given. So We already know $1 equal to 60 rupees or 70 rupees right now, maybe 75 or 76 right now the market. Okay, so as it is, ROM cost also given here. So mass code ROMs very inexpensive. Inexpensive is very cheaper, very cheaper. These are not expensive one. At factory level they are going to be designed, programmed, and time of program this is going to be working on weeks only. And time of erasing, this doesn't have erasing. So as it is, PROMs, these are inexpensive compared to MROM. These are expensive one, PROMs, that is. So this is the time of accessing, time seconds, within the seconds, EPROMs within the seconds, and flash memory 100 microseconds, and time of erasing also given. These EPROMs are 20, within 20 minutes we can erase the entire chip, and within 1 second and large blur. So the flash may be erasing the data. Just a second, I get a call. Hello. Okay, వస్తున్నారా? So here so here we are like this. Flash memories can take 100 microseconds, and if you double EPROMs it takes 100 microseconds, and within 10 microseconds the data may be erased. And then the next one is primary memory. So we already know the primary memories. So what actually is the primary memory? Primary memory also we call it as internal memory. Primary memory we also call it as internal memory, and it's accessible by processor straightly. The processor directly accessing this one. This memory includes main, cache, and as well as the CPU registers. So the next one is secondary memory. So secondary memory, what is secondary memory? This is a external memory, and it's accessible by the processor through an input-output module. This module includes an optical disc, magnetic disc, and magnetic tapes. So we discussed this one. And characteristics, performance, we already seen this one, performance and ability. So the ability of the memory hierarchy is total amount of the data the memory can store. Why? Because in case we shift from top to bottom inside the memory hierarchy, then the capacity will increases. That's the reason the entire data can be stored in memory. And access time is completely we seen that from access time from top to bottom, access time is slower. From bottom to top, access time is increases, and cost per bit from bottom to top automatically increases. So registers, cache memory, main memory, magnetic saves. So that's it. So yes, this is the today's section about So if you have any doubts, please come on to the chat box.